problem.
Okay, great. Hi, everyone. Welcome to our grade 11 math session. And my name is Batsebang Khabani. So just to make sure that everyone is in the right session, this is our grade 11 math session. And we are still doing analytical geometry. Okay, so please note down my email address. It's my name and surname @gmail.com. So my email address is my name, Batseba, and surname Nkhabani, no space, @gmail.com. So if you have questions after the session, you are more than welcome to send me an email. So during the session, please just make sure that you are on mute and your videos are off. Also, we'll have questions at the end of an example or exercise. And like I said, you can send me an email if you still have questions after the session. And we only have maths related questions in our chats. So these are the links I normally use. I use the SIYAVULA grade 11 textbook. And we're also gonna do question papers from our DBE website for all the concepts that we learn so that we can practice, okay. And also, if you missed previous sessions or you just wanna go through a session that you attended, you can just go to our Africa Teen Geeks website, or you can just go directly to YouTube and look for our channel. So you go to YouTube and look for the Africa Teen Geeks channel, and then you type in your grade and subject. Then you will have a list of all the videos from the previous sessions, whether you were part of them or not, okay. So, and then you can also follow us on Facebook, Twitter, Instagram, just for any updates, especially also with regards to our Zoom links, because sometimes they change. So just always be on the lookout on Facebook, Twitter, and Instagram to get an update of the links, and also sign up for our newsletter. Okay. So Friday, you had to complete a homework from the SIYAVULA textbook, page 112 to 113, because we covered question papers. So you had to also do problems from the textbook as practice for the work that we covered last week. Okay. So we're just gonna go through the solutions for the homework problems. Okay. So for example, in number 8, you were given a quadrilateral ABCD, so it means it's a four-sided shape, and then you are also given the points for the quadrilateral. So you can also draw it on your Cartesian plane just to see what it looks like. Okay. So For A, you are supposed to determine the equation of the line AD and line BC. So just a quick recap. If we want to draw the equation of a line, what do we need? Remember, the equation of a line is given. So the equation of a line, so it means you have to know the general equation, okay? So to determine the equation of a line, you'll probably use the equation y equals to mx plus c, okay? So you can either use this equation or you can use y minus y1, which is equal to your gradient into x minus x1, okay? So what it practically means is if you need to determine the equation of a line, you simply need a gradient, an intercept, or just a point, okay? Because if you have a single point, you can simply use this equation and then you have a gradient. Remember, the distance formula just shows you the distance between 2 points, okay? So it just shows you the length from one point to another. So this one is the general equation for your straight line. So the distance formula shows you the distance from one point to the other. Okay. Let's see if Mbali is by. Mbali?
Yes, ma'am. I understand now. Thank you.
Okay, great. So the distance formula is just what is the length between point A and B, or what is the length between point D and C. But then for our equation, we use the general equation y equals to mx plus c, which shows us the gradient of the line and the intercept. Okay, so and then they will you are also supposed to show. Remember, we said if they say show, means you have to indicate or prove that AD is parallel to BC. So for AD to be parallel to BC, what needs to happen? How do we check if lines are parallel? Guys, just try. So how do we check if lines are parallel? So to check if lines are parallel, we are gonna look into their gradient, okay? So we look at the gradient. So if lines are parallel, it means the gradient of AD should be equal to the gradient of BC, okay? So if the gradients are equal, then they are parallel. But then if the gradients are not equal, then they are not parallel, okay? And then you were supposed to also calculate the length of AD and BC. So that's where our distance formula comes in. So this is where we use our distance formula to find the length, and then we were supposed to determine the equation of a diagonal BD. A diagonal is also a line, okay. And then we were supposed to identify our quadrilateral. So we didn't know if it was a parallelogram or rhombus or kite. So we needed to identify what it is and prove, okay. And then for number 9, so in this case, you are given that MPQN is a parallelogram. So it means you can use the properties of your parallelogram. Do you see the difference? In number 9, you are given what the quadrilateral is, but then in number 8, you had to identify it yourself from the information that is given. So from number 9, you are given that your quadrilateral is a parallelogram. So it means you can use properties of a parallelogram to solve the problem. Okay. So you were supposed to determine the coordinates of one point. So you have a 4-sided shape, but then you only have 4 points. And then you had to determine the coordinates of the other point. Okay. And then you have another question where you have a quadrilateral. In this case, it is not given what it is. It's the same as number 8. And then you were supposed to, so you're given points. So you're given all the points and they want you to show them in your Cartesian plane. Remember, this is the X and Y, X and Y, X and Y, X and Y of your point, okay? So you were supposed to determine the length. So which equation are we gonna use here to determine the length? Remember, the length is the same as the distance between 2 points, okay? So if you have to determine the length, no, the length, remember the length is the same as the distance. So whenever you see length, okay, think of distance. Thanks for trying, guys. Da-da-da. Okay. So if you have to find the length, it simply means the distance. And then it means we use which equation? Which formula are we gonna use? Are we gonna use the gradient, the distance formula, or the midpoint? Remember, we have to determine the length, So we're gonna use the distance formula, okay? But the more you do the problems, you'll get the hang of it. Okay. So the distance, you have to calculate the length, and then to determine, remember the gradient is, also the slope, okay, yeah. So they would either say gradient or the slope. Okay. And then you were supposed to calculate the midpoint, which is simply the center of that distance. So this is obvious, we're going to use the midpoint formula. And then we're supposed to show that PQ equals to that, which is the same as that one. So when we show, we check using the gradient. Okay. And then to determine the equation of a line, we use this equation. Okay. And then in this question, they're asking you, is PS perpendicular to SR? How do you check if lines are perpendicular? Mbali,
Yes, ma'am.
do you understand why we're not using the gradient for number A?
Yes, I understand.
Okay, good.
Please repeat.
Mbali?
Please repeat the question that you just asked.
Okay, okay. So I said for number E, you are supposed to, how do we check? Remember we said for parallel lines, we know that the gradient are equal, okay? And then in this case, they're asking, is line PS perpendicular? Remember, this is the sign for perpendicular to SR. So how would you check if lines are perpendicular? How do we check if lines are perpendicular? We also use the gradient. Yes, we know that the angle is 90 degrees. And then in terms of, thank you for that, Lee. And then what else can we say with regards to their gradients? So we know that perpendicular lines, their point of intersection is 90 degrees, but then what else do we know about their gradients? How do we relate the gradients of perpendicular lines? Remember we said the gradient of parallel lines are equal, and then the gradient of perpendicular lines do you still remember from last week? Okay, so if we are using the gradients, remember we can use the angle to say it's 90 degrees, the angle of intersection, or we can say the product of their gradient equals to -1. Okay, so if you want to check if lines are perpendicular, you check if their gradient equals, the product of their gradient equals to -1. Okay. And then we also had to identify the type of the quadrilateral. Okay. So are you guys fine? Do you understand what you had to do? Okay. Lee?
Yes, ma'am.
Okay. Do you see that you are right when you said that the angle of intersection is 90 degrees, but we can also check their gradients.
Yes,
Okay.
ma'am. Thank you.
Welcome. Okay. So now let's go through our solutions.
Yes, ma'am. Yes, ma'am.
Okay, thank you. Okay. So for number 8, like I said, we were given all the points. And then we were supposed to determine the equation. So the first thing we were supposed to do is to calculate the gradient of AD and BC. Remember how you calculate your gradient? So for your gradient, you do change in Y over change in X. Okay, and making sure that you identify which is your point 1 and your point 2. So if you drew the diagram on your Cartesian plane, this is what you would have. And then the gradient of AD. So if we look at point A and D. Okay. Remember, this is your X and that's your Y. X and Y. Okay. So making sure that you substitute your values correctly. Okay, so just make sure that you substitute your values correctly. So for your D, you have -1 for your Y and 1 for your X. Okay. Remember, this is your X and this is your Y. Same thing here. You have your X and your Y. So these are the points for D. And then minus, you have your Y value, which is 3, and your X value, which is 0. Okay. And then that's how you would get your gradient of AD. So try to calculate the gradient of BC quickly. Because the gradient of BC, this is your point B, this is your point C. You can start either way. Even if you started with your point A here, you would have gotten the same answer. Okay. So what is the gradient of BC? Remember, it's simply you're changing Y over your changing X. So in this case, if I let my point C be my point P, point 2, it would be -1 minus 3 divided by 5 minus 4. Okay. So that's the gradient of BC. Okay. So the gradient of BC, like I said, either way, whichever value you start with, it's fine. So it will be my point 2 and my point 1. If you have B as your point 1, you will still have the same equation. Okay. So after calculating your gradient, remember they want the equation of the line. They want the equation of the line. That's why we have y equals to mx plus c. And then you use the point. You can either use A or D. You will still get the same answer. And then you solve for the one unknown, which is your C. And then you get the equation. So already from the gradient of AD and BC, the gradients are equal. So we can say the lines are parallel. Okay. So after calculating the equation of AD, you do the same thing with BC. You can play around with the points just to see if you will get the same thing. So you have your equation, but then you have a missing point, which is C, and then you substitute one of the points, either C or B, and then you solve for C. Okay. So even if you used the equation y minus y1 equals to m into x minus x1. So even if you used this equation here, you would still get the same answer. Okay, because you have the gradient and you have a point. then you can solve for y, and then you get the equation of your line. Okay, and then their gradients are equal, and you can also check the length of their line. Okay, so because their gradients are equal, then you can say that, because they wanted you to show that the gradients are equal, then they are parallel. So do you guys understand? Can I move on? And then the length will be easy. You will calculate using the distance formula. I think the most important thing is just to substitute correctly. Okay, so you will calculate the distance of AD and your BC, and you will find that they are both 17. Okay, so if you substitute correctly, you will find the lengths are the same. And then for D, you were supposed to calculate the equation of BD. So BD is still the same thing. You just calculate the gradient and use the steps that we used here. Then you will get the equation. Okay, so that's how you do that. So you still calculate the gradient of BD, and then you still use this equation or the other one to calculate the equation of the line. And then you were supposed to identify the type. So it's a parallelogram because you have sides. Remember, our AD are parallel and equal in length. So it's a parallelogram. Do you guys still have questions, or can I move on to the next one? Okay. So remember, if you still have questions, you can send me an email. This was an interesting one. So you had a parallelogram. You are only given 3 points. And then you need to find the coordinates. Okay, so because it's a parallelogram, then it means the sides are parallel and equal in length. Okay, so so you would calculate, or you would draw your graph firstly to see where N lies. Okay, so just to show you the diagram. So if you plot all these points, so you have your P, you have your Q, you have your M, and you don't know the coordinates of your N. Okay, but then according to this statement, it's saying it's a parallelogram. Okay, so it means these sides are parallel and equal in length, and also these sides are parallel and equal in length because it's a parallelogram. Okay, so you can say your point PQ, which is this length, so let's say you're working with PQ and MN. Okay, so you know that they are equal in length, and then they are also parallel. Okay, So you're trying to find the coordinates of this point. Okay, so if you calculate the gradient of PQ, you find that it's 0. So that means the gradient of MN is also equals to 0. But you are given the point M. Okay, so if the gradient of your line is 0, then it means it's a horizontal line. Okay, then it means it will go past this point. Okay, so that's why we are saying y equals to 3. Okay? And then because of the relationship that we used. Okay, and then if you have the x, the y value at this point, you can see that the length from, if you know the length from P to Q, it simply means you know the length from M to N. Okay, and the length from P to Q is 5. So this 5, the distance of 5 is in the horizontal, it's a horizontal distance. Okay, so you will try to move 5 steps away from your M to move closer to N. And when you move 5 steps closer to N, remember this is the X coordinate for your M. So if you move 5 steps, it will be 1, 2, 3, 4, 5. So it means your X is 0. Hence we have 0 and 3. Do you guys understand? So that's what you had to do. So you just had to use the information that you know about parallel lines to find your X and Y coordinates. Questions? Okay. So if you still have a question, then you'll send me an email or you'll ask me before the end of the class. Okay. So let's do the last one. So from the last one, you are given a quadrilateral, you are given points, and this is how you represent it in your Cartesian plane. And to determine the length, like I said, you use the distance formula. So you're trying to determine the length of PQ and SR. Okay, so you're still gonna use this distance formula. So just make sure that you substitute your coordinates. It's always safe to name them like, okay, this is my x2, x2, y2, x1, y1, or the other way, so that it's easy to substitute. Okay. So you determine the length or the distance using the distance formula, and then you do the same for that. And then you're supposed to determine the midpoint of PR. So you have point P, so you're supposed to determine the midpoint of PR, so it means the center of this line, okay, where this equals to side. That's your midpoint, okay? So you use the midpoint formula. And then this is your x coordinate of your midpoint. So it will be somewhere here. So, and then your x value. So your x value, it's 1. Your x value is 3/2, so it's somewhere here. And then your y, it's there. Okay. And then after determining the length and the midpoint, you were supposed to show that PQ is parallel to SR. Then it simply means we calculate their gradients. So we find that the gradient of PQ equals to the gradient of SR. So if the gradients are equal, then the lines are parallel, okay? Because their gradients are equal. If they were not equal, then they wouldn't be parallel. And then to determine the equation of the line, we need the gradient and a point. So you need the gradient and a point, then you get your equation. And then you do the same thing with SR. You determine the gradient and the point, okay? So when you see equation of a line, just think gradient and a point. So you just need a single point. And then you were supposed to explain if PS is perpendicular to SR. So what is the gradient of PS? Let's check. So the gradient of PS is 2/5, negative 2/5. And then the gradient of SR, which is this one. Okay, so let's check their product. So we need to check the product of their gradient. So we simply check the gradient of PS multiply by the gradient PS and SR. Okay. So the gradient of PS is negative 2/5. And the gradient of SR is 1/2. So we get negative 1/5. Okay, so this is not, so PS is not perpendicular because we didn't get a product of -1. Okay. So that's how. So PS is not perpendicular to SR because the product of their gradient is not equal to -1. Okay. So do you guys have questions from the work we've done today? Okay. So if you don't have questions, so for your homework, So for your homework, you're going to do the 2016 November paper, question 3. Okay. So please try that and then we'll go through it tomorrow. So try the question from our DBE website, so you will get the 2016 exam, November exam. Okay. So do you still have questions? So this week, we're gonna do our 2016 question paper and maybe one other question, and then we'll start new work on Thursday. Okay. So for now, it's just to practice calculating the gradient, showing when you're showing if like how to identify if your shape is a parallelogram or what, and then playing around with gradients being perpendicular and parallel. Okay. So once you get the hang of that, then we'll add on to that. Question? Are you fine, guys? Okay, so if you still have questions, you can send me an email. And then I'll try to help you. Okay. So remember, we're gonna do question papers and then new work.